Welcome to the next scale model. We're dealing with 1 to a septillion, and we're going to call this scale model Yotta. And Yotta comes from Greek, meaning 8, and 1,000 to the power 8 is a septillion. And so what used to be the local group of galaxies is now only about this wide. And the galaxies themselves, the Milky Way galaxy, the Andromeda galaxy, these now are like tiny grains of sand, but we only need 2 in this case. So we have the Milky Way. Let's put him at the middle of the local group. And then we have the Andromeda galaxy, which in this case is 24 millimeters away. Here, we'll get rid of these extra galaxies. These are now points of light. And as you look out, obviously you don't see stars, but if you had long exposure, this is something the natural eye can't see, but if you could use a camera, a long exposure camera, you would just see the whole sky lit up with points of light, and they're each galaxies, and there would be trillions of them. At this scale, the edge of the universe is 440 meters away. So if we combine edge to edge, that's 880 meters. And that represents the observable universe, 93 billion light years. And that is the distance to our horizon. So no matter how big of a telescope we can make in the future, we'll never be able to see beyond that horizon, at least with today's physics. Imagine it like being on a ship in the ocean, and when you look around, you just see the horizon, and you don't know what's behind it. And the only way to know is that you have to go in some direction and look over the horizon. Wherever you are, it always seems like you're in the middle. So far in this journey, in the scale models, we've been going up by rungs on a ladder, each time multiplying by 1,000. So we have 1,000, a million, a billion, trillion. We're at septillion now. So this is the last one we're at. We've reached kind of the observable universe, and if we keep going up, we just don't know. We don't know enough on what's out there. Every time we move away from our true scale, we know less and less. And so in this point in our history, this is as big of the universe which we understand. So the question is, how far does it go? So is the universe infinite? Does it go forever? Or is it finite in some way where there's always going to be a last rung on the ladder? And in the book Powers of 10, it's the same idea. You think, well, let's say we update this book in the future and we add a few pages to it. So we say, well, now we've gone 1,000,000 times larger. And historically, we've done that, right? When we went from the Milky Way to the idea that the universe is filled with galaxies, our concept grew by a lot. And so let's speculate about the future. How far are we going to go? And we could certainly think of this book as getting quite a bit thicker. Perhaps we go another billion times, another trillion times. But the question is it finite or infinite? And if it's infinite, you get to a very odd point when we think of this book, because this book would have infinite number of pages to it, right? The scale, or the rungs on the ladder in which we're creating these scale models, would never end. They would just keep going forever and ever. And this book then would need a universe that is infinite even to contain it, because the pages would go forever, and so there's no end to how thick this book is. And it's quite mind-boggling to think about it in those terms. When you keep multiplying, the numbers get really huge. On the other hand, if it is finite, you think, well, That's also a very strange concept, because what's beyond that? We used to think the oceans had an edge to them, and if you deviated too far from land, you would get to the edge of the ocean and there was a huge waterfall and you'd fall over the edge and you'd fall into the unknown. And so, obviously, a terrifying concept. Also, the idea of finite is something that is an odd thing to consider. So we're not really comfortable with either one, strangely enough. But I think, at least for me, the infinite universe is more difficult to accept. Just because having something that never ends, you think, well, that means that throughout its history it must have been infinite as well. There's no way you can jump from a finite universe to an infinite universe. Either it's infinite, or it's been finite, and it can certainly change and grow. It can evolve from a very tiny volume, but no matter how fast you grow something that's finite always remains finite. So I think, just for me, I'm more comfortable thinking of it as a finite universe. The other thing too, the universe is expanding, and the rate of expansion increases the further out you look. And so if you keep looking further and further out, the rate of separation gets so huge, it starts trending towards infinity, right? And so that's another difficult thing to accept, because certainly infinity in that sense is a mathematical concept. Whether it exists in nature to have 2 points, well, infinitely apart, you couldn't even say that, right? Every time we jump, things look different. And so in this scale model, 1 to a septillion, it's like we're in a snow globe. And the galaxies are just like stars, and we're just surrounded by that. But if we were to go much beyond this, I would just think it would look very different again. I don't think the snow globe would just be a larger snow globe. Powers of 10 has these beautiful images of how things change with scale. Part of it, of course, is the laws of physics. Out of these laws, there emerges some complexity, and from the complexity, we get to see solar systems. Then we go from there to galaxies, and from galaxies, we go to these clusters of galaxies. And we don't really know what's beyond that, but the trend so far has been that things change. If the universe is infinite, it would be hard to think how that can keep changing forever. But if it's finite, then we still need to think, well, how would this change if we look at it 1 billion times larger or so? And what laws of physics are hiding out there? Could be related to dark matter and dark energy. Things that are hiding that we'll discover eventually, that once again makes things look different. So it should be exciting. In 1,000 years from now, when we look at this book and it's updated, surely they'll have some more pages to it in the macro side, and then even on the micro side, which is at this point a place where we're going to make a U-turn. So we've reached the limit on the going up the ladder, up to 1 to a septillion, and in the next video, we're going to start going down the ladder. So we're going to start at 1 to 1,000ths. So that would be the milliscale model, and we're going to explore how the universe looks like from a micro perspective. I'll see you in the next video.